So we have widgets here, right? So what about if there are different types of widgets, right? So say there are YouTube widgets. I could drag videos on the screen. I could drag quizzes. I can drag questionnaires and homeworks. I can drag any type of widget as part of the links. So the way typically in Java, the way you would implement it is by inheritance. You would create another Java class, and you would say that I would have a YouTube video widget. Okay, and typically the way this would be implemented is that this would inherit. It would extend the widget. Okay, and typically this would inherit all the various properties such as the ID, the title, the name, all those things. Plus, it would add any number of fields that are particular to this widget. Yes, so you would have maybe a string. You would have the URL. Right. You would have maybe as Boolean. You would have whether you can embed this. Can you embed this URL, this image, this video in somewhere? You can say so, embeddable. You could have a date. Okay. Notice that in date you have two types of dates. You have Java util date and you have Java SQL date. Okay. So for our purposes, we're going to use Java SQL date, not util date. Okay. And this will be the date that it was created or published. Okay. All right. So let's generate all the methods in here, all the setters and getters, all the fields, and there we go. Right. So as it stands, this is just a plain old Java object. There's nothing new about this, right? But we want this to be implemented as a table. We want to be able to store this in the relational database, right? So to be able to do that, we're going to annotate this as an entity, right? But notice that what we cannot annotate is a primary key, right? Because we are inheriting already that primary key from widget. Widget already has a primary key, right? So let's see if we execute this. Okay, notice what it's doing, right? Notice that it did not create a brand new YouTube widget table. See that? What it's doing is that it's using a strategy called the denormalize strategy for implementing inheritance in relational databases, right? In relational databases, there is no way to implement inheritance, right? Databases were created before there was object orientation, the idea of implementing object-oriented languages, right? So there is no native way of doing that in relational databases. Nevertheless, we want to be able to capture the idea of inheritance. And so the default way of implementing it is to add several columns. You're going to add notice that the embeddable, see that, the embeddable field, it adds it to the table. It also adds published as well as another column. But then it adds this weird field called dtype. Dtype as a varchar. And it uses that to be able to distinguish when it inserts records, right, into the table, right? Be able to know whether this was implemented or when it was created, when it was in memory. Was this a widget or was it a YouTube widget, right? Because that's how it works in Java, right? When you instantiate an object, it can be either of one type or the other, right? And if it's a YouTube widget, it's also a widget, right? So it inherits all the fields plus it adds a few other fields. So if you go to the relational database and we take a look at how it was implemented, notice the widget here, right? We have ID, name, and module underscore ID. We refresh. Notice that we have 3 more fields, 4 more fields. 3 of them, I explicitly added them to our Java class, but that dtype is a managed field. This is not meant for us to be mucking around with that field. JPA will provide the value for that. What it uses the name of the original class that was used to instantiate that record. Right? If you use new widget, or if you use a new YouTube widget, then it'll use the name of the class to be able to differentiate what was the original thing that was used to implement it. Right? So if we retrieve the widgets, there are no widgets. There are no widgets. Okay. So let's try implementing a couple of widgets in here.